salt and water throughout the world, more than 70 countries. So I'm well versed with it, and I'm going to show you something very, very simple and how you can help teachers and students in the society, particularly throughout the world. How would it reach the teachers in Bangladesh teachers, or teachers in Sri Lanka, or teachers in Canada, teachers in the United States, more than anywhere else. Teachers in the United States need this kind of work, and I hope you appreciate this. Supposing you were to teach solution chemistry to a grade 11 class or grade 10 or high school science teachers, how would you approach it? Now, Romana, I asked her, what is the meaning of your name? And you know what she said? It's romantic. So I told her, we have to keep the romantic ideas of our students vivid. That's the first thing that one needs to do. If we don't use the romantic ideas of students in our teaching, we have lost the students. They don't have a handle. And I'm going to help you understand, not in terms of the so-called misconceptions that science educators are using or other educators are using. We are not exposing students misconceptions, but we want to use those ideas. We want to value their ideas. We want to help them understand their romantic ideas. Without romanticism, we cannot reach precision. So let's start with the romantic ideas. Supposing I were to have a glass of water, my hand is also shaking here, and I'm adding a little bit of salt.
Cute.
The question here is, I'm going to ask the second order questions, not the first order questions. If we ask the first order questions, they will search for book answers. But if we ask the second order questions, what do you think? Not what I think or what someone else thinks, but what do you think might be happening with salt in water when I stir? AI people, think about this, because I want you to help me. And I have stirred the water, there's salt, and then there is water. To start a solution chemistry unit, you know what the chemistry teachers will do? They'll start with the list of vocabulary. They'll say a solid, a solution,
So
solvent, mixture, homogeneous mixture, heterogeneous mixture. They will ask all sorts of questions. But do we want to start with those questions? Instead, can't we find their students' romantic ideas and have the space very important to them so that they know that their ideas are valid and they become aware of their ideas. So the question is, what do you think? You note my wording, what do you think is happening to salt and water when I add salt to the water and stir it? In the world of research and science education, in the unit on solution chemistry, we have come up with about 4 ideas. The first idea, or the first romantic idea, is the student will say, oh, the salt is melting in water. You get that? Because as you see here, of course I haven't stirred this properly, if you see here, you will see one base. So they will say, oh, it's melting in water. A second group of students might say, salt is joining with water, and they will write an equation, NaCl plus H2O equals NaCl, note my words now, NaCl dot H2O.
H2O.
That's another way of thinking about it. The third way of thinking about it is, salt has combined with water. And They will even draw pictures. There's a woman or a girl and a boy. They are holding hands and then they are dancing around in the water. So they have combined. If you ask them when I ask them, they're holding their hands. They draw the picture of a girl and a boy holding hands. What is this? They'll say they have combined water. Then the fourth one is maybe one or two students might say, oh, I see charges. So you notice in the worldwide science education research, we have 4 ways of thinking about it. You might think, oh, another group of students might say something else, another group of students might say something else. How do you reduce it to 4 ways of thinking? So over the years, I have found in different societies that there are finite ways of thinking about a phenomenon. So this is a natural phenomenon that I'm showing. So how do you think about a natural phenomenon? So I've reduced it to 4 ways of thinking. So now how do you connect this to the curriculum? AI people think hard because you're going to be helping me with these things, although I have developed two AI pieces or what do you call that? The applications. One is the seed AI, and the other one is the argue AI. What the seed stands for students, explanations, and expert dialogues. That's what seed stands for. And what is the other thing? Argue. Argue stands for, after exploring students' ideas, how do you use these 4 things? How do you help students become aware of these 4 ideas? Do these 4 ideas cover the whole solution chemistry unit? So how do you connect? One way of connecting students' ideas to the curriculum, that's very important. It's not only exploring students' ideas, but how do you connect to the local curriculum? So how do you do it? One is through argumentation. Argumentation right now takes a key place, important place in the curriculum. I don't know whether it's happening here in Bangladesh, but in North American situation, the American, the K-12 system, we have argumentation as a central place in the curriculum. So how do you move from this to that? How do you connect curriculum to the student side? So second order question is important, otherwise they might say something else. Then the argue app is very important to help students connect. Now, another important thing is we also look at emerging technologies. In the emerging technologies, there are so many things. Virtual reality, augmented reality, and they have all sorts of realities which can be used in a learning sequence. It's not lesson sequence, it's a learning sequence, because that belongs to the students. It's a personal. We are not focusing on the activities, we are not focusing on the curriculum, we are not focusing on something else, but we are totally connecting this to the students' learning. So what is the learning sequence? That's what we are connecting. And who should do that? It's a teacher. You constantly talked about the human interaction. Who is the human here? It's a teacher as well as the students. Teacher is the one who is driving the seed app. The teacher is the one who is driving the argue app. And I have 3 or 4 more apps that I want to do. And I asked the Vice Chancellor, I asked him, you know what, I have so many things in my mind, but I don't have the funds to do it. American government, I shouldn't call upon Trump, but Trump has slashed all the things. He keeps on writing to me to support him. I said, first you support me, then I will support you. So that's the kind of answer I give him. So what we need is the funds. or free, free volunteer work, like your students can do some of these AIs that I'm thinking about within a few minutes. And that would help not only the local teachers, but the global teachers. So I think I will stop with that. And you know where I'm going with this. It's for the teachers, it's for the students, and our university is taking very important role in my own research. After 34 years, my research is being recognized. Isn't that nice? And they feel that I'm going somewhere. So AI is very important, as I said, slate to AI. Let me close with one other thought. When I was student teaching at Bellingham, Western Washington University, first day I didn't even know who my faculty advisor was. He walks in, an older white gentleman. He talked to me. I was supposed to be in the teacher's room watching how the teacher is teaching. I don't know what I was doing in the chemistry lab, but I was seated there comfortably, and I was doing some deep thinking, I suppose, and this man walks in. And then at the end of his talk with me, he said, "How are you going to teach our American children?" Isn't that a funny question? How are you going to teach our American children? Right now, I have been teaching American children and the Canadian children for the last 34 years. And I'm also training a lot of PhDs. I've finished helping 25 PhDs. I have 2 more to left. I haven't still retired because we don't have retirement age, right? The American colleagues, you know that. I don't have any retirement age. So I'm going to continue to work. Probably this AI is the last piece of work that I might be contributing. For instance, I have contributed several models. One is integrating technology, or embedding technology into scientific inquiry, which I call TESI. And the other one is called the CKCN, Common Knowledge Construction. That's the picture I wanted to show you, which I haven't showed you. Maybe. Can I show you that quickly? I'll show you. I draw here. I just. See
what you're doing.
Oh, draw here. Oh, that will go there. Okay. Oh yeah, here we go. But I can't see anything here. It's all going. Anyway, the first figure is the teacher. The teacher is the most powerful person in a classroom. What the teacher says, the students must do. Otherwise, teachers are not going to be happy. And here I have several students.
Better than me.
Okay. I have several students there. Then I'm showing you. Oh, okay. I don't see the beaker there, do I? You can see the beaker? No. Beaker should be here. Okay, I'll draw the beaker here. Where do I draw the beaker? Oh, that should be brought down.
Choose the pencil.
Oh, yeah, okay. Here's the beaker that I showed you, and the stirrer, which was the teaspoon, and I have put salt into it, stirring it. Now, one student might have one idea. Oh, this doesn't work too well. Anyway, one student might have one idea. Another student might have 2 ideas. So that is called the intervariation. If the students have more than one idea, that's called the intravariation. If I have 2 ideas, it's called intravariation. If I have if Rumana and I differ in ideas, that's called intervariation. So we are collecting the intravariations and intervariations and simplifying into, anyway, I'm not going to draw this, but let me help you with this understanding. This, the teacher idea, the teacher, what she does is, or what he does is, remove herself or remove himself from the pedestal, from wherever he is there. He's moving into the student world. That is very important. We do not have, as teachers, we should not have any power over students. We have equal footing, so we need to move from our pedestals to the student world and have a particular task in mind to cover that unit, and which is the first first idea or the first task that you need to show before you even start your unit of study. And when the students give you ideas, they are intra as well as intervariations. And then we look at the teacher's world and the student's world, and we'll see how they overlap. The more the students' ideas overlap with the teacher's ideas, the better it is. That means that they are learning. And then we have what is known as the curriculum on the other side. And the curriculum has at least 4 or 5 different knowledge types. One is the macroscopic idea, the other one is the submicroscopic idea, then another one is the microscopic idea, then we have the symbolic idea. So in chemistry or in any science, we have to take these students to all these ideas. So how do we cover that? So from students' ideas to the curriculum, I like to draw the circles like this because we have to use certain investigations. AI comes in there too, learning sequences come in there, and help students move from their ideas or move from their simplistic or romantic ideas to precise ideas which the scientists have to offer. You get what I'm saying? And yeah, they have to move to that. It's only then they can pass the Bangladesh exams. Otherwise, they will not be able to go to the university anywhere else. And if we don't help students to develop their romantic ideas to precise ideas or the expert ideas, that's not schooling. We need to move from their ideas to. And students need to be aware of their ideas. So if we don't get those nice romantic ideas and move them to the precision idea or explanatory ideals that the scientists give, then we're not doing service. So valuing students' ideas is the most important thing, and moving from their ideas to the most sophisticated ideas. And that's what's called the phenomenography. The research I want to tie into this is, if you read my papers, you'll read a lot of phenomenographic research. And what is that phenomenographic research? It's a relational idea. You relate from the student to a particular, particular task. So what is the relational meaning that is there? Not, you must have heard constructivism. I'm not a constructivist, I'm a relationalist. And constructivists think only about this mind, and then they say, students come to class with their ideas. Students are not coming to class with their ideas. Students are there when they see something like that, they bring their ideas to focus on what I showed. That's what's important. It's a relational idea, and relational idea with the students, fellow students, relations with the teachers, relations with the community, relations with everything. If I keep moving on, how do you get the societal level? What do you get out of this from the to the societal level, is pollution is one of them. Water pollution is there. So these are the things that we move on to at the societal level to help them bridge from their ideas, romantic ideas, to the explanatory ideas, scientific ideas, and then to the community ideas, which is the pollution and such things. So if we need to give a total science education to students, we need to have all these things in stages covered and help them to understand. Thank you so much for your patience and listening.
Keep alive.